All right, we are going to look at section 3.2. It's about graphing quadratics that are in standard form. So these are our notes for section 3.2. Standard form of quadratic equations. So look at the form we have right here. Standard form. Y equals, or f of x equals ax squared plus bx plus c. That's the standard form of a quadratic function. Remember that to find a y-intercept, we replace the x with 0. And if we replace the x with 0, we're going to get y equals c. So our y-intercept is 0, comma c. Let's look at that. If we replace the x with 0, we get a times 0 squared. I'm just going to my function right here, replacing the x with a 0, the x with a 0, okay? We're going to replace each of the x's with a 0. And what is going to survive? We get 0. 0 squared is still 0. 0 times 0 is 0. Times a is still 0. b times 0 is 0. 0 plus c. There's our survivor, c. Right, there's our y-intercept. Should call them that, right? So y-intercept is 0, comma c. We can just look at that and read the y-intercept from the function when it's in standard form. Vertex. Instead of completing the square, this time we're going to use a shortcut. All right, not the shortcut, a shortcut. Remember the letters we've used for the vertex is h, comma, k. The h, the x-coordinate of the vertex is going to be negative b over 2a. That's a simple little formula for calculating the x-coordinate of the vertex. H is negative b over 2a. Well, I have a rule here that tells me how to find y values from x values. So if I want to know the y-coordinate of the vertex, I just take the x value of that vertex and I plug it in. H or negative b over 2a, whichever you want to call it.
Attention faculty and staff, if you're interested in a COVID-19 rapid test, please make your way down to the small gym. Once again, if you're interested in receiving a COVID-19 test, please make your way down to the small gym. Thank you.
Apologies for the interruption, but I am at the school, so that happens sometimes. All right, so remember our axis of symmetry is the vertical line through the vertex. It's going to be x equals h, or x equals negative b over 2a, because in standard form, the h is negative b over 2a. So axis of symmetry, x equals negative b over 2a. Direction of opening. Remember, if a is positive, remember positive means greater than 0. If a is positive, it's going to open up. If a is negative, your parabola is going to open downward. Okay, so positive for up, negative for down, based on what a is, whether a is positive or a is negative. All right, so based on the value of a, is a positive or is a negative? All right, let's think about what happens here with our parabolas. If we have a parabola that opens upward, it'll look something like that. I'm going to change colors here just really quick. I'm going to identify that vertex with a little red point. If that parabola opens upward, our vertex is a low point. Low points are called minimums. So if our parabola opens upward, we have a minimum value of our function. If our parabola opens downward, in other words, if a is negative, notice where our vertex is. It is now a high point. High points are called maximums. Okay, so visualize it and it'll help you remember. If a is positive, there's going to be a minimum because your parabola opens upward. Visualize what's going on. So we see we have a low point. This one, we have a high point. See over here? High point at the vertex. That's a maximum. Let's talk about domain and range just for a second. Domain is the x values of a function. When we have a quadratic function, we can plug in any x value that we want. Domain is going to be all real numbers. The range, and we'll talk about this more a little bit later on, but for now, what I want you to remember is the range is the y value. So domain is x, range is y. So when we look at this picture right here, if our vertex is h comma k, the y values are going to have a minimum of k, and they're going to go up from there. So y is greater than or equal to k. K is the smallest y value, but we have everything bigger because we keep going up, right? We'll talk more about that when we get to the graphing. So the range is going to be y is greater than or equal to k if it opens upward. In other words, if a is greater than 0. Okay. It's going to be y is less than or equal to k if your parabola opens downward. Because notice what's happening here. This point is h comma k. Our biggest y value is k, and all the other y values are going to be below that. We got to do some review on domain and range. So it's either going to be greater than or equal to k or less than or equal to k. And we're going to review a little bit with interval notation as well. Oh, I should mention that right here. Domain. Instead of writing just all real numbers with this fancy notation, we could actually write it in words. All real numbers. That's what that capital R means. Domain is all real numbers. I think we've talked about this before. Another way of writing it would be in interval notation. We go from negative infinity all the way to infinity. So we go all the way across the x-axis, from negative infinity all the way to infinity. That would be another way of writing the domain of a quadratic function. Okay, we're going to look at the first example. There will be 3 altogether. We're going to fill in the requested information for each function, and then we're going to draw the graph. So our first function, f of x equals x squared minus 8x plus 7. So a is 1. There's a little 1 sitting in front of that x squared. So a is 1. B is negative 8. C is positive 7. Oops, C is positive 7. Direction of opening. A is positive, so it's going to open upward. The vertex. If you had to explain why it opens up, it's because A is positive, right? Vertex. We're going to use the fact that the x-coordinate of the vertex is negative b over 2a. And we're going to plug in the numbers. We have the negative of negative 8 divided by 2 times 1. That's going to be 8 divided by 2, which is 4. 8 divided by 2, which is 4. Positive 4. Now, to find the k value, or the y-coordinate of the vertex, we plug in to the function. If you want to know a y value, you plug the x into the function. So we can put in 4 for the x. Everywhere there's an x, we put in a 4. So we have 4 squared minus 8 times 4 plus 7. That's going to be 16 take away 32 plus 7. 16 take away 32 is negative 16. Or you grab a calculator. 16 take away 32 is negative 16 plus 7 is negative 9. Where's our vertex? We've got the x value. It's the h. We've got the y value. It's the k. And we have spilled off of our grid. I'm going to put that on here, but it's going to spill off. Look, 7. So we went as low as 6, 7, 8, 9. We got to go a little bit lower. So 6, 7, 8. There we go. So there's our vertex at 4, negative 9. Okay, I'm going to label that. That's the point 4, negative 9. And I'm going to change colors here, and I'm going to draw an axis of symmetry. Vertical line through the vertex. He's going to be a useful tool. That axis of symmetry is a useful tool to help you graph. We'll talk more about that. Okay. Is the vertex a maximum point or a minimum point? It is going to be a minimum point because my graph is opening upward. So we get a low point. Visualize. Minimum point at the vertex. What is the maximum or minimum value? The minimum value is the y value. Okay. That minimum value is -9. It happens when x is 4, but the minimum value is -9. Axis of symmetry. Vertical line through the vertex, x equals 4. Y-intercept. We plug in 0 for x into that function. We get a y value of 7. Remember, the y-intercept happens at C. Domain is going to be all real numbers. We'll just use the capital R because it's convenient with the extra little line. And a range. Let's hold on to that one because I want to read it off the graph. Don't forget to come back. All right, so I'm going to put my intercept on the graph. Oh, he's off as well. 6. We'll go up here to 7. All right, and I'm going to plot a few more points. I want you to plot as many on there as you can. So I'm going to look and see my 4 and -9. I'm going to do a little bit on both sides, I think. If I plug in 5 for x, 5 squared minus 8 times 5 plus 7. Do that calculation. We get 25, take away 40, which is -15, plus 7 is -8. Still off of the graph. Right down there. 6 squared is 36. 8 times 6 is 48. So we get 36, take away 48, plus 7. That one was -8. This one is now 36, take away 48 is -12, plus 7 is -5. And we're still down in the negatives, but at least we're now on the graph. Okay, we have 6, -5. And use the symmetry. If we have 5, -8, we should also have 3, -8. Let's see if we do. 3 squared is 9. Take away 24, because 8 times 3 is 24. So 9 take away 24. Maybe just do some scratch work off to the side somewhere, right? 9 take away 24 plus 7. That'll be, let's see, what's 9 plus 7? That's 16. 16 take away 24 is -8. Yep, there it is. It worked, right? So that would mean when x is 2, y should be -5. Reflect it to the other side. 1 unit, 2 units, 1 unit, 2 units. There we are. Use that symmetry line. I'm going to do one more. I'm going to go down to x equals 1. See what I get. Because I want to put the point in between. I've got my y-intercept. I want to see what happens when x is 1. So 1 squared is 1. 8 times 1 is 8. Oh, that's going to be 0. Look, I found an x-intercept. There he is. Okay, that would mean my other x-intercept, use the symmetry, 1 unit, 2 units, 3 units. 1 unit, 2 units, 3 units. My other x-intercept has to be over here at 7. So I'm going to go ahead and put that in there. That's kind of weird that it came off the graph, but that's okay. All right, and then we're going to draw a smooth curve. It's not lines, it's a curve. It's not lines, it's a curve. So it's curving. Okay, notice it's curved. And we're just going to kind of draw it off the graph. And it goes up forever on both sides. Now, about that range. So about the domain, first of all, it goes forever to the left, and it goes forever to the right. See those arrows? It keeps spreading out forever to the right. Okay, so if I put a box around it, around the graph, the arrows, eventually it's going to go out, right? But if I box it in this way,
Students, if you are interested in a lunch, please go to the cafeteria. They're serving that now. Again, students, if you're interested in having lunch, it is ready for you in the cafeteria. Thank you.
or the way I often talk to my students about domain and range. Domain is the x values, so you follow it from left to right and look at the x values. It's going forever to the left and forever to the right, so negative infinity to infinity. But for the range, we go from the bottom to the top. Now, its smallest y value is negative 9, and it's going to go up from there. Okay? So negative 9 and up. Smallest y value is negative 9, but we go up forever. So from negative 9 to infinity. We can write it as y is greater than or equal to negative 9. We can write it as bracket negative 9 comma infinity. That would be the interval notation, and you'll need to be familiar with both the interval notation and the inequality notation. Okay? And that's the end of this first video.